langsung ini dibawakan khas kepada anda oleh Akademi Youtuber Malaysia. Tumpukan perhatian anda, siaran langsung akan bermula sebentar lagi. Link sijil akan diberikan di hujung siaran ini. Pastikan diisi dalam tempoh yang ditetapkan. Terima kasih.
Hai, salam sejahtera dan hai semua para guru, ibu bapa dan semua pelajar sekalian. Selamat datang ke Pusat Tuisyen Akademi Youtuber dengan usaha Sama E-Didik Malaysia dan Grab Guru Malaysia. Bermula percuma, selamanya percuma. So, cikgu perkenalkan diri dahulu. Saya Cikgu P. Kini mengajar di Kolej Tingkatan 6 Fatimah Melaka selaku moderator pada malam ini. Pada malam ini, kita akan bersiaran langsung dari channel Cikgu Hasnitah. Siapa yang belum subscribe, sila tekan butang subscribe sebagai tanda sokongan kepada Cikgu Hasnitah. So, Cikgu Hasnitah kini mengajar di SMK Bagan Jaya pada Wuf Pulau Pinang. Kita akan belajar subjek Fizik Tingkatan 5, DLP dengan bab pertama iaitu Force and Motion 2 dengan subtopik Resultant Force 1.1. So, kelas ini akan berlangsung lebih kurang 1 jam. Sebelum kita teruskan kelas, suka cikgu ingatkan kepada semua pelajar dan penonton yang ingin menghantar komen, sila gunakan bahasa yang sopan dan gambar profil yang bersesuaian untuk tontonan umum. Cikgu percaya semua yang hadir ke kelas pada malam ini merupakan pelajar-pelajar cemerlang dan mari kita tunjukkan disiplin yang terbaik. Link sijil akan diberi pada hujung siaran nanti. Pastikan diisi dalam tempoh 30 minit selepas kelas tamat. Link e-sijil ini boleh diisi dengan menggunakan sebarang email. So, sila fokus pada isi pelajaran yang akan disampaikan oleh Cikgu Hasnitah. Semoga kelas kita pada malam ini dapat dimanfaatkan sepenuhnya oleh para pelajar. So, dengan ini saya serahkan kelas kepada Cikgu Hasnitah. Silakan Cikgu.
Okey, baik. Terima kasih Mr. P, sahabat saya dari Kolej Tingkatan 6 Tun Fatimah Melaka. Apa khabar Mr. P, sihat dia?
So, baik, sihat.
Cuaca di Melaka malam ni macam mana?
Hari okey,
cerah,
tak ada hujan.
Okey, tak hujan Okey, sama juga di Penang. Alhamdulillah petang ni tak hujan, cuaca elok. InsyaAllah kita harap-harap dapat bersiaran dengan lancar. Jadi apa khabar semua penonton, guru-guru, terutamanya anak-anak pelajar yang kami kasihi sekalian. Selamat datang ke kelas tuisyen percuma Akademi Youtuber untuk subjek Fizik SPM. Malam ini kita ada kelas untuk kelas tingkatan 5 iaitu kelas DLP, tapi yang bukan kelas DLP pun anda boleh ikuti kelas ini kerana apa? Kerana slide kita adalah dalam dui bahasa. Okey, dan begitu juga bahan yang kita kongsikan, ada cikgu pinkan link dia pada live message, anda boleh download, boleh cetak keluar dan gunakan sebagai bahan tambahan dalam anda memahami tajuk ini dengan lebih baik. Jadi baiklah, sebelum kita bermula, kepada yang beragama Islam, marilah kita mulakan dengan doa belajar dan ummul kitab Al-Fatihah. Bagi yang bukan beragama Islam, anda bolehlah bertafakur mengikut kepercayaan masing-masing. Al-Fatihah. Amin, amin ya rabbal alamin. Okey, sekali lagi terima kasih diucapkan kepada semua yang bersama-sama dengan kita. Jadi tanpa membuang masa, ayo kita mulakan kelas pada malam ini ya Mr. P. Jadi Mr. P telah tunjukkan slide saya. Sebelum itu saya perkenalkan dulu barisan guru-guru sukarelawan Akademi Youtuber untuk subjek fizik yang ada. Kita kalau anda nampak di sana, walaupun ada beberapa orang guru yang tidak lagi bersama-sama dengan kita di dalam AYU, namun cikgu-cikgu inilah yang telah banyak membantu kami untuk menerbitkan video PDPC khususnya untuk subjek fizik, sama ada dalam bahasa Inggeris ataupun bahasa Melayu. Jadi anda bolehlah pergi ke channel cikgu-cikgu yang berkenaan. Kita ada Guru Cemerlang Cikgu Nora Hafizan di sana, kita ada Cikgu Izyan, yang akan memulakan tugas beliau di sebagai penolong pengarah fizik di BSTP KBM mulai esok. Tahniah kita ucapkan. Kita ada juga Cikgu Rosemawati di sana dan Mr. P sendiri, kita punya moderator pada malam ini. Dan kita ada siapa lagi di sana? Cikgu SlindaNordin, Teacher SlindaNordin, Teacher Rina Rashid dan saya sendiri Cikgu Hasnitah yang diamanahkan selaku Ketua Panitia Fizik. Okay. Dan ini adalah apps kita yang anda boleh muat turun daripada Android yang kita panggil Akademi Youtuber apps. Apa yang ada dalam apps ni Mr. P? Kita ada ribu-ribu, hampir 26,000 setakat ini video PDPC dari peringkat prasekolah hinggalah peringkat pra-universiti. Alhamdulillah video-video ini telah dihasilkan bermula tahun 2020 hinggalah kini dan jumlahnya semakin bertambah setiap hari ya Mr. P. Jadi kita harap dapat dimanfaat sepenuhnya lah khususnya untuk pelajar-pelajar di luar sana. Okay, jadi students, if you are ready and good to go, can you give us a sign? Ready teacher, sedia cikgu. Yang baru pertama kali mengikuti kelas kita juga, mungkin anda boleh perkenalkan diri. Anda dari sekolah mana? Kita ada Rashid Riza di sana. Saya tak pasti Rashid Riza ni adakah cikgu ataupun pelajar yang mungkin cikgu rasanya. Okay, terima kasih Cikgu Rashid kerana bersama-sama menyokong siaran kami pada malam ini. Okay students, if you are ready and good to go, so let us begin with our topic tonight with 1.1 resultant for 1.1 daya paduan. So if you check from your textbook on page 2 until 12, so this topic is covered from page 2 until page 12 in your textbook, and altogether it contains 4 learning standards. So for the first learning standard, you have each and every one of you must know how to describe resultant force. Anda kena tahu tulis apa maksud daya paduan. Alright, okay, so to understand resultant force, if you read through your textbook, there is one information there given on Langkawi Sky Bridge, which is located at the peak of Gunung Mat Cincang at Pulau Langkawi, Kedah. Okay, and this construction is actually the longest curved pedestrian bridge in the world for the time being. Jadi kita patut berbanggalah Mr. P, kita ada satu jambatan gantung yang merupakan jambatan pejalan kaki yang melengkung yang terpanjang di dunia untuk setakat ini. How long? Berapa panjang? Sepanjang 125 meter. Kalau anda baca di sini, digantung menggunakan 8 utas kabel pada satu pylon sahaja. Okay. Pada ketinggian 81.5 dari aras laut. Okay. So if you look at the structure, the span of the bridge, which is 1 to 5 meter in length, is suspended by 8 cable comes from a single pylon. So actually this is one example we can take when we study forces and also equilibrium of forces. Okay, how this gigantic structure can only be supported by one single pylon connect to 8 different cables. So it is one of a majestic structure and also one example of engineering technology apply in infrastructure in Malaysia. So kita patut berbanggalah kita ada satu binaan yang menggunakan kejuruteraan dan juga ilmu di dalam bidang daya ini. Okay, so maybe we have a future engineers there, so would like to generate an idea from this kind of technology. Okay, so to generate your understanding on force, resultant force. So let us take a look at this simple example. Okay, you can see there a short gift there. There are two person is playing tug of war, tarik tali, sedang bermain tarik tali di sana, and you can see there is a red flag attached at the center. Okay, so how to determine the direction of motion of the flag? Either the flag will pull to the left or pull to the right, or will it be stay at the center? Macam mana nak tentukan arah pergerakan bendera? So if you look at the red people on the left side, so actually it apply a force to the rope. So we label it as FA and directing to the left. Okay, when he pull the rope to the left. And the blue boy there, okay, apply FB, force B in the direction of right. Okay, so what happens, students, when FA is equal to FB? When both apply the same magnitude of force on the rope. So what will happen? It will cause the resultant force to be zero. So daya paduan adalah sifar, which mean the flag will be remain at the center, or it will be at rest. Okay, not moving to the left or not moving to the right. And what happen if FA is less than FB? Mean the blue boy pull with greater force. So what happened? The resultant force will be acting to the right, so the flag will move to the right, okay, in the direction of the resultant force. And the third situation, when FA is greater than FB. So what will happen if A apply a greater force on the rope? So you will see the resultant force will be to the left. So the rope or the flag will be moved to the left in the direction of the resultant force. Alright, so here is one simple example. So from here we can write, students, what is meant by resultant force. Anda boleh tuliskan apa maksud daya paduan daripada contoh mudah yang cikgu tunjuk tadi. So if you refer to your textbook, student, resultant force is defined as the single force, okay, that represent the vector sum of two or more forces acting on an object. Apa itu daya paduan? Dia adalah daya tunggal yang mewakili jumlah secara vektor dua atau lebih daya yang bertindak ke atas sesuatu objek. So the keyword is single force represent vector sum two or more forces acting on an object. Okay, so for example, we have a red car here. So you can see there are two forces acting on this car. Okay, 100 Newton acting to the right, and then we have 50 Newton acting to the left. So it shows that the car moved to the right direction of motion. So how to find resultant force acting on this car? Very simple. So we find the sum of all forces acting on the car. So we consider force to the right as positive. Okay, and force to the left consider as negative direction, because force is a vector. It has direction and magnitude as well. So to find the total, it is 15 Newton. So how to write? The resultant force acting on the car is 15 Newton to the right. Daya paduan yang bertindak ke atas kereta adalah 50 Newton ke arah kanan. Okay. Okay, so that is the first learning standard. Very simple. You must know how to write resultant force. Anda kena tahu tulis apa itu daya paduan. Okay, and then let us come to the second learning standard, students. It is to determine the resultant force. Okay, now we are going to calculate more example of resultant force in a few different situation. Macam mana nak tentukan daya paduan bergantung kepada beberapa situasi yang diberikan. Okay, so the first one, okay, this is to calculate resultant force of two forces which act upon an object on a plane. Okay, so the first case, the forces are acting in the same direction. So this is very simple. You can reply to us what will be the answer for all this example. Okay, so you can see number one, there are two forces, 2 Newton and 8 Newton, both directing to the right on this box. So just find the resultant force. So berapa daya paduan dia? So we just add 2 plus 8 will give us 10 Newton. Direction is to the right. Yes. So second example, again we have two forces acting on the same plane, mean both on a vertical plane. Okay, for this case, so we have 10 Newton to the left and then 6 Newton to the left. So what will be the resultant force, students? Can you give some response on the live chat? You can type your answer. It is okay if you got it wrong in the first time, because we are learning. Mr. Pe and I will correct you if you make it wrong. Okay, so yang penting jangan malu untuk mencuba. Okay, so what will be the answer for this? Yes, negative 16. Why negative? Because the two forces directed to the left, and we consider left motion as a negative direction. Okay, then what about the third case? 10 Newton, if you look carefully, even though the forces are right on both sides, but both is directing to the right. So you have to be careful with the direction of arrow showing the direction of forces acting. So 10 Newton to the right and 80 Newton to the right. So if you find the sum, it will be 90 Newton. So direction to the right. Okay. And the fourth example, now we have upward. Okay, two forces 30 Newton and 10 Newton acting vertically upward on this block. Okay, so again, what will be the resultant force? Apa daya paduan dia? Tambahkan saja 40 Newton. Okay, very simple. And then the last one, example. Okay, so this is the diagram given. So we have 50 Newton in this direction, another 50 Newton. They are in the same plane. So the total force or the resultant force, daya paduan yang bertindak adalah 100 Newton. Okay, senang saja. Untuk contoh yang pertama ini, cikgu harap anda dapat lengkapkan. Kalau anda tak dapat print sekarang, tak mengapa. Anda boleh print selepas ini latihan yang cikgu sertakan pada kelas ini. Ada cikgu pinkan linknya di live message dan ada juga pada deskripsi video. So you can come back later and rewatch this video to complete the answers. Alright. Okay, next. Okay, now in our second case, we still have forces acting on the same plane, but now in opposite direction. Okay, which means both one goes to the left, another one goes to the right, or one goes upward, another downwards. Okay, and so on. So we have number one. You can see this is the box. There is a force 50 Newton acting to the left and 100 Newton acting to the right. Okay, so find the resultant force. So what will be the resultant force, students? So since they are opposite, so we minus. So the answer is 50 Newton to the right. Okay, 50 Newton to the right. So since the force to the right here is greater, which is 100, so the final movement, the object will move 50 Newton to the right. All right. Okay, and for number two. So now you can see there are three forces there. 200 Newton in this direction, and then on this side 160 Newton to the right, 20 Newton to the right. So what will be the resultant force? Okay, so you add these two, it will give you 180. So then, yes, very good. So negative 20 Newton, which means the resultant force is acting to the left with the magnitude of 20 Newton. Okay, then what about number 3? Okay, before that, Mr. P boleh dengar saya dengan jelas ke setakat ini? Okay ya? Okay, bagus, tak ada gangguan.
Boleh.
So those who are watching us now, I hope you can hear me clearly. Okay, then for number 3, okay, now we have 4 forces there. Okay, we have 1000 Newton to the left, 200 Newton also to the left. Here at this side, we have 1000 Newton acting to the left, and we have 900 Newton acting to the right. Again, please be careful with the direction of arrow showing in which direction the forces acting at. So what will be the resultant force here, student? So if you calculate, you will find the resultant force will be negative 1,300 Newton to the left. So to the left here, we have 1,000, 2,000, and 200 Newton. Okay, and to the right is 900 Newton. So we minus will give us negative 1,300 Newton. Negative mean it the resultant force acting to the left. Okay, with a magnitude of 1,300 Newton. Okay, and the fourth example. Now we have 3. Now this one involve vertical plane. Okay, 1, 2, and 3 involve horizontal plane. Okay, now we have vertical plane in number 4. So 60 and 50 acting upwards, and we have 20 Newton acting downwards. So what will be the resultant force, students? Okay, so yes, it will be 90 Newton. Okay, here up here is 110. So minus 20 will be 90 Newton. Okay, and the last one for this case in the opposite direction. So you can see we have, this is the plane involved. We have 20 Newton in that direction, another 40 Newton, and then we have 60 Newton to the opposite direction. Okay, so what will be the resultant force here? Okay, so if you look carefully, so the resultant force will be, yes, it will be 0 Newton. Okay, 60, total 60 to this direction and another 60 to the opposite direction on the same plane. Okay, so that goes with the second situation. Okay, now we have the third situation. When the two object is now perpendicular to each other. Perpendicular mean they are at the right angle, 90 degree to one and another. So how to find the resultant force now? Macam mana nak cari daya paduan bagi dua daya yang berserenjang antara satu sama lain. Berserenjang means 90 darjah di antara satu sama lain. So anda tengok di sana kita ada dua daya 6 Newton dan 8 Newton pada sudut 90 darjah. So we have two forces, 6 and 8 Newton at the right angle from one and another. So this is the steps which guide you how to find the resultant force. Okay, so first, you can consider these two forces as a side of a rectangle. Okay, so imagine these two are a sides of a rectangle. Okay, and then second, what you need to do is complete this diagram with the side representing the two forces that are perpendicular to each other. So you draw a dashed line here to complete our rectangle. Okay, the condition is the length of these two lines must be the same. Okay, the upper line same length with the 8 Newton, and then this line is same length with the 6 Newton. Okay, and then what we have to do next? Okay, you have to draw the diagonal of the rectangle. So this is the diagonal showing by the yellow arrow. Okay, the diagonal of the rectangle represent the resultant force of these two forces. And then finally, we can calculate the length of the diagonal using Pythagoras theorem. Remember, you learn in maths Pythagoras theorem. So we can use Pythagoras theorem to find the resultant force, which is also the diagonal of the rectangle. And then finally, we can also calculate the angle between the diagonal and one side of the rectangle by using trigonometry. For example, this is the angle theta in between the resultant force and the horizontal plane. So we can find the angle using tangent theta. Okay, 6 is the opposite side, and then 8 is the 10 is the hypotenuse here, but here we can also use 10 opposite to adjacent side. Okay, so opposite side is 6 and adjacent side to this angle is 8 Newton. So we'll give us 0.75. And then we just press your calculator. Okay, so we will find the angle is 36.9 degree. Okay, so this is the step which can guide you to find the resultant force involving two forces which are perpendicular to one and another. Okay, then students. Okay, what about this? This is the second method we can use. Other than using Pythagoras theorem, you can also use scale diagram method. Anda boleh menggunakan kaedah lukisan berskala juga untuk mencari daya paduan bagi dua daya yang berserenjang tadi. So when talking about scale diagram, so there are two methods. The first method we can use triangle of force method. Anda boleh lukis kaedah segitiga daya. Okay, how to apply this method? Very simple, but you need this apparatus. Okay, first you must have a protractor. Okay, second you must have a ruler and of course a pencil or pen to draw. So protractor is a must and a ruler as well. So for example, this is the diagram you are given. Okay, for this one, the case is the two forces are at an angle which is not perpendicular to one and another, mean at an angle which is not 90 degree. Either more than 90 degree or less than 90 degree. So you can use this method. Okay, so let's say this is the diagram we are given. Okay, so there is a force 5 Newton in this direction, another 5 Newton in this direction, and they are at an angle of 120 degree to one and another. So how to use triangle force of method? Very simple. Okay, first you have to determine your scale of drawing. Okay, let's say we choose a scale here. 1 centimeter will represent 1 Newton. Anda pilih skala dulu. 1 centimeter lukisan mewakili 1 Newton. Okay, which mean for 5 Newton, how long we should draw this line? So we should draw 5 centimeter long. Okay, this one also, we should draw a line 5 centimeter long with this scale. Okay, and then, okay, this is the complete drawing, students. So first, you can draw this one. Okay, let's say this 5 Newton is F1. So you draw from this point 5 centimeter using ruler, a straight line. Okay, and then what to do? You can place your protractor here at an angle 120 degree as shown in the question. So place your protractor here 120 degree, and then you can place your ruler here, letak pembaris anda di sini, draw another line 5 centimeter to represent the second 5 Newton force, the second force. Okay, so finally, you connect the end of the first force to the head of the second force. Or you join the tail of the first force to the head of the second force. That's why this method also called as tail to head method. Okay, this method, triangle method, also known as tail to head method, because in the end, you're going to join the tail of F1, this is F1, to the head of F2. So this will be our resultant force. So how to find the magnitude or the value? You just place your ruler here and measure the length of this line. So let's say here the length is 8.8 centimeter. Okay, and then we multiply with our scale. Remember, each centimeter represent 1 Newton, so 8.8 centimeter. So the resultant force will be 8.8 Newton. Okay, simple, right? Okay, next. Okay, this is the second question. Now we have force 50 Newton at an angle of 70 degree with the second force 70 Newton in this direction. Okay, so how to determine the magnitude and the direction of the resultant force? So again, first we pick our scale. Let's say here now we use 1 centimeter represent 10 Newton. Okay, 1 cm represent 10 Newton. Okay, so we begin our drawing with, you can begin with anyone. Okay, you can begin with 50 or you can begin with 70. But the thing is, you must follow the original direction of the force. Okay, let's say I draw the force of 50 Newton first. So how long I must draw this line? So I draw 5 centimeter long to represent the 50 Newton force in this direction. So this is the first force, 50 Newton. Okay, this one, the first force, 50 Newton. Okay, then I place my protractor here, student. So place your protractor here and measure the angle 70 degree. Okay, from this line, 70 degree. So this is where you will draw this second force of 70 Newton. So you place your ruler here and measure 7 and draw a line for 7 centimeter long. Okay, so this is our second force. Okay, direction here. Okay, so now how to find the resultant force? Again, so this is the tail of head 1, the tail of F1, which is 50 Newton. This is the tail. And this is the head of F2, 70 Newton. So this is the head of F2. So we join this tail to head, so it will give you this line. Okay, if you measure with the ruler, let's say the length is 7.1 centimeter. So you have to follow your drawing. Okay, so this is my drawing. Its length is 7.1 centimeter. So by that, I can find the resultant force by multiply 7.1 to my scale, 10 Newton for each centimeter. So it will give me 71 Newton for this question. Okay, easy, right? So this is triangle method. Okay. And the second method, student, you can use another drawing method, which is called parallelogram method. Okay, so parallelogram, again, you need a protractor and a ruler, okay, to apply this method. Okay, let's say this is the two force we are given, okay, 5 Newton in this direction, and there's another 5 Newton and they are 40 degree to one and another. Okay, so how to draw? So first, we can pick our scale. So here I use, because the force is very small, so I choose a scale 1 to 1. So my drawing will be just nice, not too small or not too big. Okay, enough to fit in an A4 paper. Okay, students, so this is my scale. So I begin. Okay, so this is the full drawing. Okay, so how to get this drawing? Very simple. So let's say I started draw this one, 5 Newton. So I draw a line 5 centimeter long. Okay, to represent this 5 Newton. Okay, this one, this is the direction. Okay, 5 Newton. And then what is the next step? I place my protractor here at this end, okay, and measure 40 degrees. So this is 40 degree. Measure from this line of F1. Okay, 40 degree. So once I get the angle, so now I place my ruler here. I draw this F2 for 5 centimeter length. So this will be the line as you can see here. Okay. So this is the line. I draw the arrow for you so you know the direction. Well, okay, so this is my pen. Okay, this is F2. Okay, so this is our F1, F2. Okay, then what is the next step, students? Okay, you need to draw another line here which is parallel to this line. Okay, and then another line up here which is parallel to this line. Okay, and then final step, we draw the diagonal. Okay, the diagonal. So this is the diagonal of this parallelogram. And then as before, so you measure the length. So the length of the diagonal is 9.4 centimeter long. Okay, so we multiply with our scale. So the resultant force here is 9.4 Newton. Okay, 9.4 Newton, parallelogram. Okay, and actually if you notice parallelogram is double the triangle method. Kalau triangle anda lukis sebelah saja. So for parallelogram, you have draw both sides. Okay. Okay. Then second example. Okay, we try this. B. 300 Newton in this direction and then 400 Newton in this direction. They are at 130 degree to one and another. Okay, so now since our force is quite big, 300, so we use a bigger scale as well. So 1 centimeter represent 50 Newton. Okay. So let's say I draw this line first, 400 Newton. So 400 Newton with a scale of 1 cm represent 50. So I should draw a line which is 8 centimeter length as shown here. Okay, so this one 8 centimeter length to represent this 400 Newton. Okay, and then this is the angle 130 degrees. So I place my protractor here and I measure this angle 130 degree. Okay, so this is where I should draw my second force, 300 Newton for how long? So with this scale, so 6 centimeter long. Okay, 6 centimeter panjang. So this is the line represent the 300 Newton. Okay, then I complete the parallelogram, okay, as shown here, and this will be the diagonal. Okay, the diagonal is in this direction, which means the resultant force is somewhere in this direction. Okay, the resultant force as shown in this diagram. So the length I measure with ruler is 6.2 centimeter. So don't forget to multiply with the scale. So 6.2 times 50, it will give 310 Newton. Okay, as the resultant force. So I hope you are clear with all this method in how to find the resultant force involving different cases. Okay, the first case, object on the same plane, in the same and opposite direction, and then we have two forces which is perpendicular to one and another, and the third case, the two forces are at an angle which is not perpendicular to one and another. Okay, so Mr. Pei, what if we take a short break for a while? Boleh kita
Okay,
rehat
so boleh. Okay, so before we continue for the next learning center, okay, so let us take a break first. Okay. Okay, so welcome back. So let us continue the next learning center together with Cikgu Hasnitah. So silakan Cikgu Hasnitah.
Okay, thank you very much, Mr. Pei, and also to those students who are still with us. Thank you very much for your commitment. We really appreciate all your efforts. Okay, yang masih lagi bersama dengan kita, kita teruskan dengan standard pembelajaran yang ketiga. So this is our third learning standard for content standard 1.1 resultant force is to communicate about resultant force when the object is stationary. Second, moving with constant velocity. And the third, when the object moving with constant acceleration. So ada 3 keadaan kita nak lihat. Yang pertama, objek berada dalam pegun, tidak bergerak. Yang kedua, objek bergerak dengan halaju seragam. Ketiga, objek bergerak dengan pecutan seragam. Okey. So how to determine the resultant force acting in all these cases? So first, we can discuss the resultant force acting on an object with the aid of a free body diagram. Okay, free body diagram. You must know how to draw a free body diagram to show all forces acting on the object. Apa itu gambar raja jasad bebas? Ia adalah satu objek gambar yang menunjukkan semua daya yang bertindak ke atas objek itu sahaja. So free body diagram is a diagram that shows all forces acting on the object only. For example, here we have a table which is placed on a table. So how many forces you can see there, students? Okay, so you can see there are 2 forces. The first one is the weight of the book acting downward. And then second force is the normal reaction, okay, from the surface of the table. So these are the 2 forces acting. So if you are about to draw the free body diagram, so you just draw these 2 arrow, R upwards, W downwards, without need to draw the books. So free body diagram just show all forces acting on the object. Okay, same goes with the second example. We have a wooden block is hung by a string. Ada satu blok kayu yang digantung pada spring. So there are 2 forces there. The first one is the weight of the block acting downward. Berat blok itu ke bawah. And what is T, student? T is the tension of the spring. T ini adalah daya pada spring. Okay, daya pada spring T. So it is acting upward. So if you ask to draw the FBD, free body diagram, so you draw this red arrow. T upwards, W downwards. Simple. Without need to draw any spring or any wooden block there. Okay, so itu adalah gambar raja jasad bebas. Okay, then. Okay, so this is another diagram show to you the free body diagram. So here we have a bag which is placed on an inclined plane. So how many forces you can see there? There are 3 forces acting. First is the weight acting downwards. Okay. Second, we have N. Okay, with the pink arrow there. N is the normal reaction from the weight here. Okay, which is used to prevent the bag from sliding. Okay, and then we have the third forces is R. R is the normal reaction from the inclined plane. Normal reaction which is 90 degree to the inclined plane. So if you are about to draw the free body diagram, so we just draw R, N, W. Okay, and for the next diagram, this is a moving trailer. So how many forces you can see acting on this trailer now? The first one is always the weight of the trailer downwards. And then there is a normal reaction which is opposite to the weight upward. Okay, and then the forward force, or here the pulling force. Okay, and finally is the frictional force, the force in between the tire of the trailer and the road surface. So there are 4 forces there. So if you are about to draw the FBD, so you draw these 4 forces only. R upward, W downward, T forward force, and then frictional F backward force. Okay, 4 forces acting. Same goes with this rocket. Okay, so for this rocket, if you look carefully, there are 3 forces acting there. The first one is the thrust, or the forward force acting upwards. Okay, second is the weight of the rocket acting downwards. And then we have a third force there, which is the air resistance. Okay, air resistance. So the FBD, thrust is above, weight downward, air resistance downward. So 3 forces acting on the rocket. Alright. Okay, that is free body diagram. Okay, and then student, now let us take a look at the situation where it shows forces acting on an object in a different state of motion. So we have a white car there. So this white car now in 3 different state of motion. So first, it is at rest or at stationary. Pegun, dia tak bergerak. So when the car is stationary, how many forces you can see there? There are 2 forces acting. Okay, the first one is weight, second is the normal reaction. Okay, then what about the velocity? Since it is not moving at rest, dia pegun, so velocity is 0. Okay, laju dia sifar. And what about the acceleration? So since velocity is 0, so acceleration also 0, no motion at all. So what will be the resultant force? The resultant force is 0, where W is equal to R. Okay, let's say W is 100 Newton, example. So R also 100 Newton, but in the opposite direction. Okay. Okay, now the second state. Now the car is moving with uniform velocity. So if you look at the FBD, how many forces acting on the car? Now there are 4 forces. The first 2 is weight and normal reaction. And then we have the forward force, which is called thrust. Okay. And the frictional force acting backward, opposite to the thrust. Okay. So by this uniform velocity, which means velocity is constant, uniform. Laju dia tidak berubah, malar. Okay. And then what about the acceleration? So since velocity is uniform, where final velocity is equal to initial velocity, so acceleration 0. Okay, resultant force 0, which means W equal to R, okay, and T equal to FR. Okay, Cikgu Agila, terima kasih. Thank you very much for supporting us, my old friend in Akademi Youtuber. Cikgu pengajian untuk tingkatan 6. Juga rajin buat kelas Cikgu Agila ni. Again, thank you my friend. Okay, then kita bandingkan. So here W equal to R, W sama dengan R dan T sama dengan FR. T equal to FR. Alright. Okay, then for the third state student, untuk yang ketiga, so now this car is moving with uniform acceleration. Okay, uniform acceleration, which means the velocity increases uniformly. Okay, increases uniformly. Okay, let's say it increases 2 meter per second for each second. So 2 meter per second, 4 meter per second, 6 meter per second, 8 meter per second, 10 meter per second for each 1 second. That is meant by uniform acceleration. Okay, so what happened to the velocity? Definitely velocity is increasing. Okay, laju dia bertambah. So acceleration, since it is uniform, so the acceleration, there is a value. So acceleration not 0. Okay, acceleration is not 0 and it is uniform. Let's say 2 meter per second all the time from 0 second to let's say 10 second. Alright. Okay, then for the resultant force, so it is not 0. Since it is accelerating, so then which means T will be greater than FR. Okay, so F is not 0. There is a value for resultant force. So this is how to find the resultant force. T thrust minus with the friction. Okay, so you'll find there will be a value. Let's say 20 Newton is the resultant force. Mean the car accelerating forward with the resultant force of 20 Newton. Example. Okay, and this is how we compare all forces acting. W equal to R because the direction is in a horizontal plane. Okay, so W equal to R and T greater than FR. Okay, the thrust greater than the resultant force, showing that it is accelerating. Okay, so I hope you are clear with this. So you can complete your table if you have download or print out your student PDF copy. I prepare and empty spaces here for you to fill up. So you can fill up later on if you didn't have a printer back home now. Okay. Then students, okay, this is the next case. Now we have a drone, okay, involving vertical motion. Okay, so this is the FBD. The first state of motion, the drone is now at the ground where the engine is switched off. Okay, dia pegun di permukaan tanah. So this is the free body diagram showing that W is equal to L. W is the weight and L is the lifting force. Alright. Okay, so what happened now at this state? Acceleration 0 since it is not moving. Resultant force also 0, which means W balanced to L. W equal to L. Okay. And now the drone is started flying. Okay, it moved upward with acceleration. So it moved upward with acceleration. We understand if you draw the FBD, L will be greater than W. How to show in our drawing L is greater? Normally we draw the greater force with the longer arrow, showing the magnitude is bigger. So L greater than W, so it is accelerating upwards. So acceleration is now not 0. Okay, it accelerates. So there is a value for the acceleration. And resultant force also not 0, where we can find the resultant force by minus the lift with the weight. Okay, so there will be a value. It is not 0 Newton. So comparison, L greater than W. And the third situation, it is now moving upward with constant velocity. Okay, constant velocity, what is meant by constant velocity? Constant velocity, now L back to equal to W. L now back to equal with W. Lifting force equal to the weight. So acceleration 0, resultant force 0 since W equal to L. Okay, so again also you can complete this table with acceleration, resultant force and comparison of forces acting on the drone. Alright, okay, next. Subjek fizik wajib luluskan nak sambung ukur bahan. Ukur bahan tu untuk engineering ke? Kalau kejuruteraan, kita ada kejuruteraan bahan dan sumber. Yang itu fizik adalah fundamental lah, salah satu subjek yang asas. Saya tak pasti kalau ukur bahan tu, kami tapi ada info untuk pos ukur bahan. Is fizik a must? Subjek fizik wajib lulus ke nak sambung ukur bahan? Mungkin kena ada lah kot. Yang pertama matematik lah. Saya rasa matematik kena lulus. Okay. Mungkin fizik itu satu advantage kalau anda ada lah. Okay.
Tapi fizik tak susah untuk lulus sebenarnya.
Iya, betul. Kalau nak tanya untuk lulus tu memang tak susah, Mr. Pace. Asalkan anda baca, jawab. Kadang-kadang yang belajar last minute pun boleh lulus sebenarnya fizik ni. Cuma yang susah tu nak dapat A lah. Kena betul-betul rajin. Kalau nak dapat A, kena konsisten. Buat latihan setiap hari. Sebenarnya apa subjek pun sama bagi saya, Mr. P. Kalau anda ada usaha, rajin tanya guru, semua boleh lulus. Tapi kita tak naklah target lulus saja, kita nak distinct. Kita nak target cemerlang. Sebab sekarang ni siapa-siapa pun boleh lulus, tapi tak semua orang boleh lulus dengan cemerlang. Okey, jadi Cik Riza ke saudara Riza, minta maaf kalau tak menjawab dengan tepat, tapi mungkin fizik itu perlu dalam ukur bahan, tapi yang wajib itu matematik lah, yang paling utama. Okey, harapnya berpuas hati dengan jawapan. Okey, ataupun kalau tak puas hati boleh mungkin cari daripada sumber-sumber yang lain juga. Okay, so students, okay, now we continue with our final learning standard. Dah sampai hujung dah, Mr. P. Another 10 minutes to go. Okay, so this is to solve problem involving resultant force, mass and acceleration of an object. Macam mana kita nak selesaikan soalan-soalan yang melibatkan daya paduan, jisim dan pecutan sesuatu objek. Ya, sama-sama. Afwan Rashid Rizal. Yeah. Okay, then for the first example, here we have an object that is moving horizontally or vertically. Okay, for our first problem solving, we look at the situation where the object is moving horizontally or vertically. Kita tengok contoh yang pertama, objek bergerak secara ini menegak lah. Okay, vertically. Kelapa ni dia jatuh, dia akan jatuh menegak. Dia tak akan jatuh secara mengufuk. Sebab dia gravity, it fall due to gravity. So the coconut will fall vertically from its tree to the ground. So you are given information there. It shows coconut of mass 2 kg. Okay, falling with an acceleration of 9 meter per second square. So kelapa ni berat dia, jisim dia 2 kilo, dia jatuh dengan pecutan 9 meter per saat. Okay, so first, sketch the free body diagram of the coconut. Baru cikgu ajar tadi, lakar gambar ajar jasad bebas. So how to sketch? So remember, you don't have to draw any coconut or tree there. So just show the forces acting. So first you must know how many forces acting on the coconut when it fell to the ground. Ada berapa daya yang terlipat di sana? So the first one definitely is the weight. Okay, yang pertama adalah berat. Yang kedua kita ada R. R here is actually represent air resistant. Dia bukan normal lah, R ini air resistant. Rintangan udara apabila dia jatuh. Okay, so these are how we draw the free body diagram showing two forces acting. The first one is the weight, berat. Second is air resistance, R. Okay. Okay, then B, calculate the resultant force acting on the coconut. Hitung daya paduan yang bertindak ke atas buah kelapa. Okay, so in this case, they didn't give us any number for the air resistance. So actually we can ignore. So this is the information. We have mass, acceleration, so we can find resultant force by using Newton's second law of motion formula. Okay. You have learned this formula in Form 4 when we learn 2.6, okay, force under force and motion 1. Okay, so this is the formula, Newton's second law, F equal ma. So mass is 2, acceleration in 9, which means the resultant force is 18 Newton. Okay, the resultant force is 18 Newton, which is also the weight of the coconut. Okay, sama dengan berat kelapa. Okay, then state the direction of the resultant force. So in which direction? So since the coconut accelerate downwards, which mean the resultant force is in a downward direction. Pecutan dia ke bawah, jadi arah daya paduan adalah ke bawah juga. Okay. Then next question D. What is the magnitude of the air resistance acting on the coconut? Sekarang kita boleh kira dekat sini. Okay, we can find the magnitude. Kita boleh kira rintangan udara yang bertindak ke atas buah kelapa. Okay, so this is the gravitational acceleration. Okay, the gravitational acceleration. So just now we find the resultant force is 18 Newton. Okay, so now we are given G. So when we are given G, we can find the weight of the coconut. Okay, so when we know the weight of the coconut, we can find the air resistance by minus this with the weight of the coconut. So how to do? Very simple, student. So this is the resultant force acting. Okay, where do I get this from? Very simple, from our FBD just now. So you understand this is the direction of the coconut, the direction of motion. Okay, so down here we have W. Okay, so from the FBD we draw earlier, W is acting downward. Okay, and then our R is acting upward. R is air resistance. Okay, which means, so W has the same direction with our motion, which means the resultant force is W. Okay, and R has opposite direction with our motion. So we minus. Okay, we minus. So this is our resultant force. F, resultant force, is W, the weight, minus the air resistance. So we just do the substitution. So just now, the resultant force, we get 18 Newton from B. And W, how to find W? Remember, W is weight. So weight equal to mg. Mass multiply gravity. So mass is 2 kg and this is G. So minus R. This is what we are looking for. So how to find R? So we multiply this. It will give you 19.62. So we bring R to the other side. Here and 18 Newton, okay, back here. So which means air resistance is 1.62 Newton. So we understand when the coconut fall, it has overcome air resistance of 1.62 Newton to produce resultant force of 18 Newton. Okay, so I hope you are clear with that. Okay, next question. Okay, we have a car now involving horizontal motion. Okay, horizontal motion. The yellow car, there are two forces acting. Okay, the forward force is 9,000 Newton. Okay, it's the thrust, forward thrust, 9,000 Newton. And the frictional force between the car and the ground is 7,000 Newton. So we understand this is the direction of motion of the car moving to the right. So the question asks you for acceleration. So acceleration is A. So how to find A? Again, this is the information we are given. The car has a mass of 1,000 kg and this is the thrust or the forward force. We label it as T, 9,000. The friction, let's say we label as R, but sometimes also label with F, subscript R. Okay, 7,000. So we are looking for A. So what formula we can apply here, student? Yes, Newton's second law of motion formula, F equal ma. So this is our formula, F equal ma. Okay, Newton's second law. So F here represent resultant force. So resultant force, so this is our resultant force in this direction. So student, it is T. So here is T. T same direction with F. So R opposite direction. So our resultant force is T minus R. So equal to ma. So 9,000 minus 7,000 will be equal to 1,000 A. So to find A, so it is 2 meter per second squared. So finally, what happened to the car? It accelerate to the right with 2 meter per second squared with a resultant force of 2,000 Newton. All right. Okay. Next. Okay, then now we have a case where a person is in the elevator. The next case. Case yang kedua, penumpang di dalam lift. Okay. Person in an elevator can be in a few different situations. The first one, elevator is stationary. Okay, or move up or downward with uniform speed. So stationary or move up and downward with uniform speed. So at this state, the resultant force acting is 0. So you can see the FBD, there are two forces there. W is the weight and R is the normal reaction. So this is the relation between all these two forces. So F is the resultant force. Okay, R minus mg, or it can be mg minus R if it move downward. So which mean R equal to mg. Mg is weight. Okay, mg is weight. So R equal to mg. So if this girl stand on a weighing scale here, the weighing scale will read the actual weight of the girl. Okay, where R is the reading of the weighing scale, it will be equal to the actual weight of the girl. R equal mg. Okay, second case, now the lift move upward with acceleration of a meter per second. Okay, the lift is now accelerating upward. Okay, so how to find the resultant force upward? So now when accelerating upward, we understand R will be greater than W. Okay, R greater than W. W is mg. So from this formula, F equal to ma. So resultant force R minus mg. Okay, R same direction with the motion, so it is positive. W is opposite, so that's why we minus. Okay, then R, we write the R as the subject, so R equal to mg plus ma. So what happened here? The reading will be greater than the actual weight of the girl. So as if that the girl will be feel heavier. Okay, when the lift accelerating upward. So the weight plus ma. There is additional reading on the weight. Okay, then the third case, the lift is now accelerating downwards. Okay, accelerating downwards. So when accelerating downward, of course, R will be less than W, or W will be greater than R. So we write here R less than weight, which is mg. So to write the resultant force now downward, so it is mg, which is W minus R. So which means the reading of the weighing machine will be less than the weight of the girl. Okay, this will be the reading mg minus ma. So when the lift accelerating downward, the girl will feel lighter compared to its actual weight. Okay, example. Let us take one example of situation here. We have a person standing on a lift which is stationary. Okay, it say weighing machine during the lift is stationary. So now the lift is stationary. So it shows the reading of 600 Newton. So 600 Newton is the actual weight of this person. Okay, so the question here, what is the reading of the weighing machine if the lift accelerate upward with 2 meter per second squared? So just now we understand when accelerate upward, the reading will be greater than the actual weight. Okay, so this is the formula. When accelerating upward, R minus mg equal to ma. So this is the formula. So R, the reading, is mg plus ma. Mg is the weight, so plus ma, this is due to the motion. Okay, force due to the motion. So m, how to find mass? Very simple. 600 divide 9.81. So we'll give you 91.16 kilogram. Multiply 2, the acceleration is given. So the reading is now 722.32 Newton. All right. Okay, then student. Now the third case involving a pulley. Okay, pulley. So this is the pulley system. It shows a 2 kilogram object is pulled upward with this force. So when we pull here 30 Newton, this 2 kilogram will accelerate upward. Okay, so find the acceleration of this box. Okay, given G 9.81. So first you must understand. Okay, this is all the given information. Mass 2 kg. T is the force applied here of the rope here, okay, or the string. And W is the weight of the block. Okay, how to find this? 2 times 9.81. So it will give you the weight of the block, 19.62 Newton. So find the acceleration, student. So we apply F equal to ma. Okay, so F is the resultant force acting. So resultant force acting, we have T minus W. Okay, why T minus W? Since this object is moving upward, so W is opposite to the motion. So T minus W, 30 minus 19.62 give you 2A. So by this, the acceleration is 9.12 meter, 5.19 meter per second squared. Sorry. Okay. Second case involving pulley. Now the pulley is in this arrangement. Okay, this is the pulley. This is the first block placed on a table. The second block Y is hang down here, and it say that X and Y connected by a string over a smooth pulley. Okay, when the system is released, X and Y accelerating at 4 meter per second squared. So this is the direction of motion of the 2 kg. Accelerate 4 meter per second in this direction. And the 3 kg accelerating 4 meter per second squared downwards in this direction. So this is the tension of the pulley, T. This is the tension of the pulley here. And F is the friction. Okay, W is the weight of the 3 kg block. So these are all the forces acting on this system. So they ask us to find the frictional force. So we are looking for F, frictional force. So how to find, student? Actually, you can break this component into two parts. First, the vertical component. Okay, vertical involve this. Okay, so how to write the force involving vertical component? So this is the resultant force, W minus T. Okay, this is the direction of motion. So W minus T equal to MA. Okay, this is the weight of W with 3 kg minus T. T we don't know, it is an unknown. So this is MA, 3, acceleration 4. So by this, we find the tension of the string here is 17.43 Newton. So here is 17.43 Newton. Here also 17.43 Newton. Okay, now we can find F by considering the horizontal component, this one. The 2 kg is moving horizontally. So how to find the resultant force? So you can see there are two forces there, T and F. So T minus F equal to MA. Okay. Then T we calculated earlier. So this is the mass of this block. Acceleration is 4. So by this, the friction is 9.43 Newton. Okay, simple, right? So if you are given this diagram, so you can break them into two components of vertical and horizontal each. All right. Okay, so I guess we have come to our final exercises, Mr. Pei. So this is formative practice 1.1 in your textbook. I believe most of you have done this because most of us are now in chapter 2. Okay, so you can take this session as a revision as well, preparation for your incoming exam this June. All right, so we have number 1. Find the magnitude and direction of the resultant force in the following situation. So this is as what we did earlier. Very simple. Okay, the first one, we have 3 forces there, 9 and 17 to the right and 11 Newton to the left. So this is how to find the resultant force. 9 plus 17 minus 11. So the resultant force is 15 Newton to the right, 15 Newton ke kanan. Okay, this one, 5 and 2 is upwards and 13 Newton downwards. So the resultant force is negative 6 Newton. Negative 6 means it is moving in a downward direction with a force of 6 Newton. Alright. Okay, and question 2, we have a ball there. There are 2 forces which is perpendicular to one and another, 180 and 240 Newton. So first they ask you to sketch the diagram to show these forces. So you sketch. So this is how we sketch. Okay, 240, 180, and don't forget the angle here, 90 degree. Okay, so sketching done. B, calculate the magnitude of the resultant force. So where do you think the resultant force will be? So it will be somewhere here. So we can use Pythagoras theorem since they are right angle to one and another. So how to use Pythagoras theorem? Okay, first, you can use also drawing method, okay, to find the resultant force. So the yellow arrow or the diagonal show to you the resultant force. Okay, B, how to find? So we are using Pythagoras theorem. F equal to 180 squared plus 240 squared and then the square root, the answer. So by this, the resultant force is 300 Newton. Okay, students. And finally, the direction of motion. So in which direction the ball will move. So how do we say this direction? Okay, you can say upper right or it is to the northeast. Okay, ke arah timur laut. Bolehlah itu ada arah daya. Okay, so northeast or upper right. Okay. So, Mr. P, I guess that's all for tomorrow. That's all for today. Alhamdulillah, kita dah berjaya habiskan kelas pada malam inilah. So, cikgu harap sedikit sebanyaklah dapat membantu anda untuk faham tajuk ini dengan lebih baik. So, yang baik itu daripada Allah, yang kurang itu semua daripada kelemahan diri saya. Dan semoga kelas pada malam ini membawa manfaat kepada semua yang mengikutinya. Okey, saya serahkan kembali kepada Mr. P. Silakan Mr. P.
Okay, so terima kasih kepada Cikgu Hasnitah. Selesailah kelas kita pada malam ini. Tahniah dan terima kasih diucapkan kepada semua yang setia mengikuti kelas dari awal hingga ke saat ini. Okay, so sebelum kita tamatkan sesi siaran langsung,
Mr. P mungkin boleh kongsikan link sijil kepada penonton kita pada malam ini?
Ya. Okay, so link sijil sudah saya sharekan di chat room.
Okey, anda boleh lihat pada skrin kita ada sediakan e-sijil untuk semua pelajar yang ikuti kelas fizik. Jangan lupa kita ada 2 kelas. Kita ada kelas pada hari Jumaat 9.30 malam. Iaitu 2 hari yang lepas disampaikan oleh Cikgu Izyan. Tajuknya 1.1 kuantiti fizik. Okay, so untuk tahun ini kelas tingkatan 4 adalah pada hari Jumaat Mr. P 9.30 malam. Dan untuk kelas tingkatan 5 iaitu kelas DLP pada hari Ahad masih lagi sama, cuma kita telah bertukar waktu siaran. Kalau dulu kita bersiaran pada 3.30 petang, tapi pada tahun ini kita bersiaran pada pukul 8.45 malam. Okey, so itu sekali lagi link sijil Mr. P dah kongsi. Anda jangan lupa isi, sijil dia cantik Mr. P, boleh buat collection, boleh buat koleksi. Dan boleh guna sebarang email untuk isi link sijil. Cuma kita minta jangan kongsikan kepada sesiapa yang tidak menonton siaran langsung ini. Itu saja. So sijil ini khusus untuk siapa yang follow kita secara live pada setiap kali kita ada kelas. Dan anda ada 30 minit untuk mengisi selepas live ini tamat sebelum kita tutup. So lepas after 30 minit we will close. 30 minit kita akan tutup lah link ni, lebih kurang sekarang ni hampir pukul 10, dalam lebih kurang 10.30 kita akan tutup lah link kelas ini. Okey, itu saja pada saya. Dan Mr. P mungkin ada nak promo kelas pada minggu hadapan?
Ya, kelas minggu hadapan akan diadakan oleh saya lah. Okay, so 8.45. So share lah kepada kawan-kawan, okay, untuk manfaatkan semua. Okay, so saya rasa di sini sajalah. So terima kasih kepada semua penonton Akademi Youtuber. Doakan kami terus kuat dan bersemangat untuk membantukan dalam membangunkan pendidikan di Malaysia. Okay, so sekian daripada saya. Dan kita jumpa lagi lah.
Okey, jumpa lagi. Assalamualaikum dan selamat malam semua.